Here is a question. You see the question. Let us go for the solution. The equation given in the question can be rewritten as 2y plus 2 cos x dx minus sin 2x dy equals to 0. Now you know this is m and this thing is n. Del m by del y equals to 2. Del n by del x equals to minus 2 cos 2x. Now we get 1 by n del m by del y minus del n by del x. This thing 1 by del n means 1 by minus sin 2x, and this thing in the bracket will be 2 plus cos 2x. Simplifying this thing we get minus 2 cot x. Now integrating factor will be e to the power minus this thing minus 2 cot x dx, and simplification gives us 1 by sin square x. Now we can multiply this thing with sin square x. Multiplication gives us 2y cosec square x plus 2 cot x into cosec x dx minus 2 cot x dy equals to 0. Now this is an exact differential equation which can be written as minus 2d cos x minus 2 dy cot x equals to 0. Integrating we get cosec x plus y cot x equals to c. Now in the question it is given that x equals to pi by 4. X equals to pi by 4 means this will be root 2 and this thing be 1. So 1 equals to c. So c y at pi by 4, sorry this thing is wrong, at x equals to pi by 4 this will be root 2, and y at x equals to pi by 4 is given 1 minus root 2, and cot x will be 1 for pi by 4 equals to c. So c equals to 1. Thus here we put c equals to 1. So this thing becomes cosec x plus y cot x equals to 1. Now from here we can find y equals to sin x minus 1 by cos x. Now we tend x tends to 0 first. Tending limit x tends to 0, LT x tends to 0, y becomes minus 1. So C is correct. Option C is correct. And LT x tends to pi by 2, tending x pi by 2, y becomes, this thing will be 0 by 0. So we, according to L'Hospital rule, we differentiate numerator and the denominator. This gives us cos x by minus sin x. So this becomes 0. So D is also correct, because tending x and x tends to 0 and x tends to pi by 2, we get a finite value. So C and D are correct options.